Hello everyone, today we are going to do packet switcher of SRWE 2 version 7, 3.4.5. Packet switcher configure trunks. Addressing table. Objectives part 1, verify VLANs. Part 2, configure trunks. Background. Trunks are required to pass VLAN information between switches. A port on a switch is either an access port or a trunk port. Access port, trunk port. Access ports actually are the ports that are directly connected to the end devices. So here on S2, these three ports, F011, F018, F06, these three ports are access ports because they directly connected to these three PCs. Trunk ports are the ports between switches. Here, these two ports, G01 and G01 on S1 and S2 are trunk ports because these two ports are between two switches. Access ports carry traffic from all specific VLAN assigned to the port. A trunk port by default is a member of all VLANs. Therefore, it carries traffic for all VLANs. So trunk port carries traffic for all VLANs. Carry all the information from different VLANs and transmit them to the next switch. This activity focuses on creating trunk ports and assigning them to a native VLAN other than the default. Native VLAN, what is native VLAN? We know that a trunk port carry traffic for all VLANs. Here, the traffic include tagged traffic and untagged traffic. Tagged traffic, here look at these three VLANs, VLAN 10, 20, and VLAN 30. These three VLANs are data VLANs, which are configured to separate the user-generated traffic. The user traffic from these VLANs must be tagged with its VLAN ID. So the traffic from these VLANs are tagged traffic. Another type of traffic is called untagged traffic. Like a management traffic from management VLAN are untagged traffic. Management VLAN include SSH, Telnet, HTTP, HTTPS, and SNMP. And the untagged traffic are generated by switch. And untagged traffic may come from legacy devices as well. And when a trunk port receives an untagged traffic, it will put this untagged traffic into the native VLAN. So that is the native VLAN for the untagged traffic. Instructions, part 1, verify VLANs. Step 1, display the current VLANs. On S1, issue the command that will display all VLANs configured. There should be 10 VLANs in total. All 26 access ports on the switch are assigned to VLAN 1. Let's go to S1. Okay, enable show VLAN brief. So here it says 10 VLAN in total. Let's count here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So totally 10 VLANs are configured. And the 26 access ports. Here, this switch has 24 fast Ethernet ports and 2 gigabit Ethernet ports. So totally 26 ports. And by default, all these 26 ports are access ports, and all are assigned to VLAN 1. On S2, S3, display and verify that all the VLANs are configured and assigned to the correct switch ports according to the addressing table. S2, enable show VLAN brief. Okay, so all the ports are displayed here, 26 ports. They are access ports by default. Remember that. But this here on S2, F011 is assigned to VLAN 10. F011, VLAN 10. F018 is assigned to VLAN 20. F018, VLAN 20. F06 is assigned to VLAN 30. F06, VLAN 30. Okay, good. And S3, enable, show VLAN brief. Okay, here, all the ports are here. They're access ports by default. And F011, VLAN 10, F011, VLAN 10, F018, VLAN 20, F018, VLAN 20, F06, VLAN 30, F06, VLAN 30. Yes, correct. So step 2, verify loss of connectivity between PCs on the same network. Ping between hosts on the VLAN on the different switches. Although PC1 and PC4 are on the same network, they cannot ping one another. This is because the ports connecting the switches are assigned to VLAN 1 by default. In order to provide a connectivity between PCs on the same network and the VLAN, trunks must be configured. Let's go to ping from PC1, ping PC4. PC4's IP address is here, 172.17.10.24. It's ping 172.17.10.24. This ping should fail. That's because on S2, the port F011 is assigned to VLAN 10. On S3, F011 to VLAN 10. But in the middle, all the ports between switches are still in VLAN 1. So that's why the ping from PC1 to PC4 fail. Here, the fail, it shows fail. That's why we need to configure the ports between switches as trunk to solve this problem. So part 2, configure trunks. Step 1, configure trunking on S1 and use VLAN 99 as the native VLAN. Let's go to S1. Okay, configure terminal interface range G01-2. Okay, switch port mode trunk. And configure VLAN 99 as the native VLAN for G01, G02 on S1. So switch port trunk native VLAN 99. Okay, the trunk port takes about a short time to become active due to a spanning tree protocol. Click fast forward time to speed the process. Okay, here the message come out. The message shows native VLAN mismatch. That's because we configured this G01, G02, these two ports, the native VLAN, VLAN 99 as native VLAN, but these two ports on S2 and S3, the ports G01, G02 are still in VLAN 1 by default because we don't configure VLAN 99 as native VLAN for these two ports yet. So the message shows native VLAN mismatch. But here is, although you have a native VLAN mismatch, ping between PCs on the same VLAN are now successful. Let's go to ping again from PC1 to PC4. This time the ping is successful. So I explain why, even though the native VLAN mismatch, but the ping is still successful. That is because the DTP involves DTP stands for Dynamic Trunking Protocol. DTP involves to help automatically negotiate the other side of the trunk link. Okay, like here, we know that S1, the two ports G01 and G02 has been configured as trunk. So the G01 on S1 will automatically negotiate with G01 on S2. And the G02 will automatically negotiate with G02 on S3. So after negotiation, these two ports, G01 on S2 and the G02 on S3, will automatically turn into the trunking status and become a trunk port from access port. Because we mentioned in the beginning that all the ports on switch are access ports by default and assigned to VLAN 1. So now these two ports automatically turn into trunk port. So solve this problem. So that's why even though the native VLAN mismatch, but still ping is successful. That is the reason. Step 2, verify trunking is enabled on S2 and S3. Let's go to S2. Use the show interface trunk command to confirm the DTP has successfully negotiated. So here the DTP, Dynamic Trunking Protocol. Trunking with S1 on S2 and S3, the output also displays information about the trunk interfaces on S2 and S3. You will learn more about the DTP later in the course. Okay, here, show interface trunk. So here, S2 is here, the G01 status changed to trunking. Okay, the mode is auto, is a dynamic auto negotiate. Okay, after negotiation, this port become a trunk port from access port. And S3 show interface trunk. Okay, after negotiation, the G02 here, G02 status change to trunking, mode auto, dynamic auto negotiation. So G02, these ports become a trunk port from access port. And what a question. Which active VLANs are allowed to across the trunk? On S2, let's look at here. Okay, this VLANs, VLAN 1, VLAN 10, VLAN 20, VLAN 30, 88, 99, these VLANs are active and allowed to cross the trunk. S3 is the same. VLAN 1, 10, 20, 30, 88, 99 are active and allowed to cross the trunk. Okay, we answered this question. Next. Yeah, from here we can see the native VLAN S2, native VLAN G01, still VLAN 1 by default. So we still see the message native VLAN mismatch. On S3 is the same. Native VLAN is VLAN 1 on G02. Okay, so we still see the message native VLAN mismatch. Okay, so now we need to fix this. So correct the native VLAN mismatch on S2 and S3. Configure VLAN 99 as the native VLAN for the appropriate interfaces on S2 and S3. All right, so S2. Okay, configure terminal. Interface G01. It's 2, yes. So switch port trunk native VLAN 99. Switch port trunk native VLAN 99. Yeah. Okay, let's verify. Show interface trunk. Okay, now the native VLAN changed to VLAN 99. The before is native VLAN is VLAN 1. So it changed. Okay, good. And let's do the same thing on S3. On S3, the interface should be G02. Configure terminal interface G02. Okay, switch port trunk native VLAN 99. Okay, let's go to verify. Show interface trunk. Okay, native VLAN changed to VLAN 99 now. Before it's VLAN 1. Yeah, we changed. So show interface trunk command verify. Yeah, we did it. And next is verify configuration on S2, S3. Show interface switch port command to verify the native VLAN is 99. Okay, S2. They ask us to show interface G01. What's that? Switch port. Right here, native VLAN 99. Yes, correct. And S3, show interface G02, switch port. Okay, here, native VLAN 99, correct. All right. So here, yeah, completion status is 100%. That means we perfect finish the configuration. Here is why is port G01 on S2 no longer assigned to VLAN 1. Okay, let's see. Show VLAN. Okay. Here. Show VLAN. It's a G01 on S2. Here, the S2. So now there's a port missing, which is the G01. G01 is not here anymore. Why? That's because, as we said before, all these ports displayed here are access ports. All right. And by default, these ports are assigned to VLAN 1. But now G01 has turned into the trunk port. So it is not access port anymore. The trunk port is a member of all VLANs. It carries all VLAN information, but it doesn't belong to any specific VLAN. So it is no longer assigned to VLAN 1. So here, the G01 is no longer assigned to VLAN 1. That is the answer. All right, so we finished this packet tracer, configure trunks. Thank you for watching my video. If you like my video, please thumbs up and subscribe my channel and share with your friends. See you next time.